Hello good day viewers, welcome back to Tambol Academy. In our previous lesson we have talked about numbers and we have seen that numbers are classified based on what? Real and the imaginary numbers. Where the real numbers are the most important part of numbers. And these real numbers are classified into what? Rational and irrational numbers. And we have seen that the rational numbers are also the most important part of what? Real numbers. And these rational numbers are the numbers you can express as numerator over the denominator. And the universal set, that is the set of numbers that contain all other rational numbers, we say it is what? The integers, the set of integers. And set of integers are the numbers you can see on the number line. You can see we have a number line here. From the origin 0, if you go to the right, you have 1, 2, 3, 4, 5 to positive infinity. If you go to the left, we have -1, -2, -3 up to negative infinity. We say this set of numbers are called integers denoted by z. And all other rational numbers falls under here. In between 0 and 1, we have some numbers, fractions or decimals, right? In between 1 and 2, we have other numbers, but they are not classified under integers. So we're going to talk about these rational numbers because we have seen that rational numbers are numbers you can express as what? Q divided by P, right? Where our denominator will never be equal to 0. We don't want any situation that will make our denominator to be equal to 0. Because whenever you have a situation where the denominator is 0, we say the whole system is said to be undefined. So let us start with integers, numbers on the number line, before we go to subset of integers. Take any number at random here. Let's take 2. We say that 2 is a rational number because you can express 2 as what? Numerator over the denominator. 2 is always equal to 2 divided by 1. Both 2 and 1 are all integers. Therefore, 2 is a rational number. Take any number to the left-hand side. For example, -7. -7 is the same thing as -7 divided by 1. So any number you take here, you are free to divide it by 1 and it will remain the same. Therefore, all set of integers are said to be rational numbers. All right? And remember that both numerator and denominator have to be what? Integer. So if this is true, what about the numbers in between them? We have no problem with natural numbers because I told you natural numbers are the counting numbers, which is denoted by this n, the natural numbers, the counting number that start from what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. And whole numbers are the numbers that begins with 0. So from here to this direction are called the whole numbers, right? Whole numbers. And if you go to the left-hand side, you have only the negative integers. So we have no problem with natural numbers and whole numbers because any one of them can be expressed as a rational number, right? But I told you we don't want any situation that can make the denominator to be equal to 0. But this is not where the problem lies. The problem lies in between these integers. In between these integers, we have some decimal numbers and we have also some fractions, right? So let me take a number here, or let me take it here. If I should take in between 1 and 2, you may have what? 1.5. Is this 1.5 a rational number? Definitely 1.5 is a rational number because it can be expressed as what? 1.5 equal to 15 divided by 10. Because you can see this one has one decimal place, right? So to migrate this decimal place to the last digit, all you have to do is to multiply by 10. And when it comes to equivalent fraction, I don't want to talk much about these numbers because this is just the starting point. But I know if I divide 15 by 10, I'm going to get 1.5. And 15 divided by 10 can also be reduced to the lowest step because 5 can go into 15 3 times. So this is the same thing as 3. And 5 can also go into 10 2 times. Therefore, you can see that 3 over 2, which is a fraction, right, is the same thing as 1.5. And since it can be expressed as numerator over denominator, we say that 1.5 is also a rational number. You may have 1.3 somewhere here, right? 1.3. 1.3 is the same thing as 13 divided by 10. Therefore, 1.3 is also a rational number. But I told you in our previous lesson, we have 3 different types of what? Decimal numbers. We have the terminating decimals, like this one. You can see this one has 1 decimal place. Immediately, it terminates. Sometimes you may have non-terminating decimals. For example, you may have 0.3333. It keeps on recording. This one is non-terminating. Look at it. Non-terminating, but what? Recording, because 3 keeps on repeating itself. So how can I determine whether this is what? A rational number or irrational number? I think we have to discuss about this one. That is non-terminating decimals and also recording decimals in a separate video to learn how to convert them into fractions, which are what? Rational. I know this is the same thing as 1 divided by 3. Take your calculator, divide 1 by 3, you're going to obtain this one. And therefore, since 0.33333 can be expressed as 1 divided by 3, it implies that 0.333 is also a rational number, right? But the question is, how can we convert this one to this? Because we have seen that 1.5 is just the same thing as 15 divided by 10. We cannot just say 33 divided by 10 or 100. It is not possible, but I'm going to show you in a separate video on how to convert non-terminating decimals that are recording into fractions. I think this is all we have here, right? In between here, we have the fractions and decimals. And we have the whole numbers, the natural numbers. They are all under integers. And all of these numbers are said to be rational. So let me repeat. Rational numbers are just the numbers you can express as numerator over the denominator. You know, the top number is called the numerator. We are going to talk about fractions separately. It's just the starting point. Thank you for watching. Do share to your learning colleagues. Bye-bye.